Welcome to Lesson 5 of Module 2.1 in the course called Geometry. Today we're going to talk about the biconditional statement. When a conditional statement and its converse are true, you can combine them into a biconditional statement, a statement that contains the phrase if and only if. So if your conditional statement is true in both directions, it's a biconditional. Conditional statements are bi if they go both ways. So a biconditional statement, you have to have your conditional statement and its converse true. And we combine them into, instead of saying P implies Q and Q implies P, we can shorten that into P if and only if Q. And the symbol is P if and only if Q. Also, you might see one more abbreviation. They don't show it in this book, but I've also seen this. P IFF dot Q, P if and only if Q. And if you recall from our last lesson, for definitions, the conditional statement and converse are pretty much the same thing. You can call it if P then Q, you can call it if Q then P. So any definition can be written as a biconditional statement. Here's an example. Let's rewrite the definition of perpendicular lines from the last lesson. Awesome! As a single biconditional statement. If two lines intersect to form a right angle, then they are perpendicular lines. So that was our conditional. So P is going to be two lines intersect to form a right angle. Q is their perpendicular lines. And then, so we're going to write it as P implies Q. That's our conditional. Same thing we had up here. Then we'll write the converse. Q implies P. So if two lines are perpendicular, then they intersect to form a right angle. And then the biconditional with this P and Q would be P if and only if Q. So two lines intersect to form a right angle if and only if they are perpendicular lines. And so that, in that statement by itself, that includes both the original conditional and the converse. Alrighty then, let's take a look at one more example. Here is the definition of congruent segments. If two line segments have the same length, then they are congruent segments. Here goes the converse. This was if P then Q, so let's do if Q then P. If two line segments are congruent, then they have the same length. Now we want to put those together into a biconditional. So two line segments have the same length if and only if they are congruent segments. So there you go. That's how to make a biconditional statement. Just want to point out one little thing, that these two biconditionals are logical equivalents. Just switching which one's called P, which one's called Q, but they both mean the same thing. Two line segments have the same length if and only if they're congruent segments. Two line segments are congruent if and only if they have the same length. Same-o, same-o. But when you write it, you only have to pick one. And if they tell you what P is and they tell you what Q is, then put them in P first, if and only if, then Q. All right, well, you are awesome, and you know it. So clap your hands, and remember to remain awesome at all times. Have a sweet day.